been about systems of equations. And so if you think or remember what a system of equations is, it's two or more equations together, and you're looking for the points that they have in common. Okay? Now with equations, it's just the line and the line. So if they cross, it's just that point. But we're going to talk about systems of linear inequalities. And if you remember from yesterday, you have the line and the shaded area. Right? So it's not just the points on the line, it's also all the points either above the line or below the line. So today, the solution isn't going to be like just one point. It's going to be an area, because they might have a ton of points in common, not just one point in common. What we're going to do today is we're going to graph two inequalities on the same graph. One thing that I like to do is I like to use two different colors of highlighters, or maybe two different colors of pens, or two different colors of colored pencils. Maybe even if you just have like a pen and a pencil, but two different colors of writing utensils. Because what we're going to need to do is we're going to need to be able to identify the area that they have in common. And I think that's easier to do if we have two different colors. And you'll see what I mean here in just a second. So if you want to go ahead and get out, like I said, highlighters seem to work the best. But if you don't have highlighters, that's fine. At minimum, like a pencil and a pen. But what works best is two different colors. Okay? Now, with systems of linear inequalities, okay, the steps are going to be super similar to just graphing linear inequalities, not systems of linear inequalities, because we're basically doing the same thing, except there's two of them on the same graph. So let's talk about these steps here. So to graph a system of linear inequalities, the first step, kind of the same, except since I have two inequalities, we need to solve both inequalities for y. Solve both inequalities for y. So both of the inequalities need to say y equals or x equals. Okay? Same second step, you are going to go ahead and graph. But since we have two inequalities, you're going to graph both inequalities. Now remember, whenever we're graphing them, you do have to be careful because you may have a shaded or a solid line if it's an equal to. You may have a dotted line if it's not an equal to. So pay close attention to that. After you graph it and pay close attention to the line, you are going to go ahead and shade both inequalities. And what usually is going to happen is that when you shade, maybe you shade this inequality over here and this inequality up here, there's usually going to be some area that's just shaded in, so I'm going to use yellow and green for my two inequalities. So there's probably going to be some part of your graph that's just shaded in yellow and some part of your graph that's just shaded in green. What you're looking for is the area that you shaded for both inequalities, which is why I like using the both colors, because you're looking for the area that you shaded with both colors. So what you're going to look for is your solutions. Your solutions are in the double shaded area. Solutions are in the double shaded area. So guys, this is like seriously the same thing we did yesterday, except there's two inequalities on the same graph. So let's try this one here. So first one, we have y is greater than 2x minus 5. Okay, so for this one, it already is in y equals. So we could go ahead, we could graph this one. The y-intercept is at -5, so we would come down here at -5. My slope is 2, or 2 over 1, so we're going to rise 2, run 1. What we're going to want to do today, and I didn't really stress this a whole lot yesterday, we want to go ahead and make sure we're extending our line all the way across the graph, including the shaded area. So I might go ahead and plot maybe a couple more points just so I can get a nice straight line. And then remember from yesterday, before you connect your line, you need to decide if it's a solid or a dotted line. Notice this one, okay? It is a greater than. not a greater than or equal to. So remember, these points on these lines are not part of this solution. So we are going to use a dotted line for this one. And then just like yesterday, we're going to shade what the inequality tells me to. And it is a greater than, so we are going to shade above the line. Okay, now, like I just mentioned, we want to try to do a really good job of make sure you shade everything above the line. Because if you don't shade it all, if you just kind of shade a little bit, you may miss the overlapping part. So we want to make sure we're shading all of that. All of these are solutions for that green inequality. And then we're going to turn around and we're going to do the exact same thing with the second one, except the second one is not in y equals. So with that second one, we first need to solve for y. So we're going to subtract 3x from both sides. So we would have 4y is less than or equal to negative 3x plus 12. Divide by 4, and as long as it's a positive 4, no problems. So we'll do y is less than or equal to, and then make sure you do the butterfly method. Negative 3 over 4 would just say negative 3/4 x. 12 over 4 would be a plus 3. And then we can graph this line. So the y-intercept is at 3. So up 3 and put a point. The slope for this one is negative 3/4. So we're going to go down 3 over 4 and put a point. If you want, you could go up 3 left 4, but that will kind of go off the graph a little bit. You can do that if you wanted to. And then before you connect it, is this going to be a solid or a dotted line? Solid, because it has that equal to. And then this is the part where you kind of just have to ignore what you already graphed, okay? We're just looking at what I have graphed in orange here, okay? And remember, look at the inequality that you graphed. Since it's a less than, we are going to shade below the orange line. So you really just ignore what I shaded at green. We're looking at the orange line, and we're going to shade everything that's underneath this orange line here, which mine is kind of hard to see because the highlighters aren't the greatest here. Now, technically, you're done. This is all you have to do. So whenever we had linear equations, we were looking for the point where they cross, so you could tell me, this is the answer, this is the point where they cross. But with inequalities, it's not going to be just one answer. There's like a whole group of answers here. Okay, so let's break down what we have here. Okay, so we have this area right here, this top area, like this top triangle here. This area is just shaded in green. These points are a solution only to that first inequality. That's not a solution to the system. Okay? This area down here that I have only shaded in yellow, that's a solution to the yellow inequality. But notice it's not shaded in green. It's not a solution to that first one. So that's not a solution to the green inequality. That's not a solution to the system. See this area over here, this right area over here, it's not shaded for either one. This isn't a solution for either one of them. See this last area here that I have shaded in both colors? All of these points, every single one of these points in here is a solution to the system. Which means you could pick any point in here, plug it into both inequalities, and it would work for both inequalities. These points are your answers. And you can't really say those points, right? You can't write them all out. So our graph is our answer. Okay? All right, let's get this glued in. This should be our last section in chapter 6. It's going to be section 6.6, and it is systems of linear Inequalities. All right, first one, number 1. Let's graph y is greater than or equal to 2x minus 1 and x plus y is less than 2. All right, so I'm going to go ahead and maybe sketch out my graph a little bit just so I have it and make things a little easier to graph here. And we're going to go through, we're going to graph both of these inequalities. So remember, to graph an inequality, it has to be in y equals. That first one's already in y equals. So we can plot the y-intercept at -1. So right here. My slope is 2, or 2 over 1. So we're going to rise 2, run 1, and put a point. Now before you connect it, look at your inequality. Solid or dotted line? Solid line. And then last thing, for this one, it's a greater than or equal to. So let's shade above or below? Above. Good. Now remember, on your homework, it's going to be a worksheet, so you'll just want to shade that entire half of that graph. For this one, just kind of give it quite a bit of room, because we are going to want to make sure we can identify the places where they overlap. Now the second one is not in y equals. This is a pretty simple one. To get into y equals, we just need to move the x. So we're going to subtract x from both sides. So we have y is less than -x plus 2. So my y-intercept is at 2. My slope is -1, right? -1 over 1. Notice the numerator's negative, but the denominator's positive. So make sure you go down 1, right 1. Down 1, right 1. And is this one going to be a solid or a dotted line? Here, solid. This is going to be a dotted line. Make sure you give a nice big long line there. And then remember, you always want to go to the inequality that we're graphing. So if y is less than, are we going to shade above or below? Below. Now, this is the one you just need to take an extra second. We're looking at, it's the one that I have graphed in orange. So you're going to graph, so you're going to shade everything below the orange line. But we know, okay, this area over here that I've shaded just in yellow, that's not a solution to the green inequality. I'm looking for the points that's a solution to both. This area here at the top, that's only a solution to the green inequality. This area right here, okay, that I've shaded in both, that's where your answers are. These are your solutions. Those are the points we're looking for that I've shaded in both colors. Okay, let's try another one, number 2. Y is greater than 3x minus 2 and 2y minus x is less than or equal to 6. And I'm going to go ahead and sketch out my graph a little bit and get that done. And then remember, we're just graphing 2 inequalities on the same graph. So they have to be in y equals. The first one, already in y equals. My y-intercept is at -2. My slope is 3, or as a fraction, 3 over 1. So rise 3, run 1. Look at your inequality. It's a greater than, so is it a solid or a dotted line? Dotted, right? Because it's not an equal to. And remember, going a nice long line all the way across your graph. And then remember, there are points, there are solutions either above or below the line. Since it's a greater than, where will I shape? Above the line. And then we'll go to work on the second one because it is not in y equals. Now remember, this one's a little backwards in a way because we're solving for y. Okay, we still are going to move the x term first. It's a minus x. To move a minus x, we're going to add x to both sides. So I would have 2y is less than or equal to x plus 6. And then we get rid of the 2. Divide everything by 2. So we have y is less than or equal to. Remember, we talked about it yesterday. This x over 2, anytime you have x over 2 or just your x over a number, you want to write the 1 in front of the x and then kick the x out of the fraction. We're going to call it a 1/2 x. And then 6 over 2 gives me a plus 3. So my y-intercept is at 3. My slope is 1/2. So we're going to rise 1, run 2. If you want to go down and left the other way, you definitely can. Is this one going to be a solid or a dotted line? Which one? Solid line, very good. A solid line. And go to the inequality you're actually graphing. It's a less than or equal to. So where will I shape? Where will I shape? Less below it, right? Yeah, we'll shape below the orange line. So once again, what you're looking for is you're looking for these points here, the points that are shaded in both colors. This is your answer right here. Okay, this double shaded area. Is making sense? Okay, let's do 2 more. Okay, number 3. Y is less than 2x minus 3. And y is greater than 5. Okay, let's go ahead and set up our graph. So that's done. Notice this one's kind of nice because they are both already in y equals for me. So that first one, my y-intercept is at -3. So we'll go down 3 and put a point. My slope is 2 or 2 over 1. So rise 2, run 1. Solid or dotted line? Dotted, right? Because it's not an equal to. It would have to be an equal to if it was a solid line. Because a solid line means that those points are a solution. And since it's a less than, where will I shape? Below. Below the line. Now the second one's also in y equals. What do you notice about the second line? It is greater than. What do you notice about this one? It doesn't have an x. It is a y only line, right? So on your y-axis at 5, you're going to draw what kind of line? A dotted line. And then, will I shade above or below that line? Above that line, yeah. So your answers, your solutions is going to be that tiny little area over there. And actually, I know it looks like a little tiny area, but remember, your answers, right, this shaded area keeps going. I just didn't graph that much. But it does keep extending this way. Okay? All right, last one. Number 4. 6x minus 5y is less than 15. And 10x plus 20y is greater than or equal to 60. Give yourself a little bit of room underneath your problems just because neither one of these is in y equals. So we're going to have to do a little bit of work for each one of these. All right, so both of these, neither one's in y equals, so I have a little bit of work to do with both of them. So the first one, let's move the x term, so subtract 6x from both sides. So we have negative 5y is less than negative 6x plus 15. And remember, when I divide by a negative 5, you have to flip the sign. So it's going to turn to a greater than. Now when you do the butterfly method, negative 6 over negative 5 is going to turn to a positive 6/5. 15 over negative 5 is going to give me a negative 3. So we can go ahead and graph this one. Down 3, put a point. My slope is 6/5. So we'll rise 6, run 5. All the way over here. Let me put a point. And is this going to be a solid or a dotted line? Dotted, good. Big long line there. And if it's a greater than, shade above or below the line. And we have to look at this one. It's a greater than? Above. Yep. You have to shade using the inequality of the one you're graphing. Okay, now this second one you have to be kind of careful, and this is going to happen on your homework today. Okay, we're still going to put it into y equals, which means I still need to move my x terms, so we're going to subtract 10x from both sides. So we have 20y is greater than or equal to negative 10x plus 60. Now when I divide by 20, this is going to happen on your homework, okay? We have y is greater than or equal to. When you do negative 10x over 20, it doesn't divide out evenly, but you can reduce that. You don't want to leave it as 10 over 20. What would 10 over 20 reduce to? Negative 1/2 x. And then 60 over 20 would give you a plus 3. You want to make sure you reduce your slope whenever possible. So your y-intercept is at 3. Slope is negative 1/2. This one is going to be a solid line. And it's a greater than or equal to, so this one is also shaded above